Tonight we're going to talk about analyzing the velocity graph and the second derivative graph. So this is really a continuation of the lesson from the last video, analyzing the graph of the first derivative. You're going to see a lot of similarities in velocity because, of course, velocity is simply the first derivative of position. And so we're going to actually be using a lot of the same processes that we used last time, and then we're going to look at the second derivative graph and analyze and be able to answer some questions from that. Again, very common AP questions, so make sure you take great notes. Okay, this first example in analyzing the graph of a velocity function. So it says the graph of v of t representing the velocity of a particle moving along the x-axis on the closed interval 0 to 20 consists of one semicircle and 4 line segments as shown above. Okay, so the first thing I'm going to do, and as we get better and better at these, maybe you don't feel the need to make the sign charts, but until that happens, I just think it really helps us to very clearly answer the questions. So I'm going to very quickly go ahead and sketch my velocity sign chart, and I'm also going to do one for acceleration. Okay, so we're on the closed interval from 0 to 20. All right, and the first thing I want to do is recognize that this is the velocity sign chart. So I'm looking for my zeros. I'm looking for when does velocity equal 0? In other words, when does it cross through the x-axis? Okay, so you can see that happens for the first time at 8, and then again at 13, and then again at 20. Okay, so I'm going to go ahead and put in those values here. So those are going to be my zeros. Okay, I can't really tell what's happening at 0. Can't tell if the graph is cutting short or if it's going to pass right to the left of it. It kind of looks like it is well, but that's not really as important. All right, so then I'm going to go through and just say, what is the velocity graph doing? Is it positive or is it negative in those intervals? So between 0 and 8, what would I say about where the velocity function is graphed? I would say that it is below the x-axis, therefore it is negative. Okay, between 8 and 13, though, it's above the x-axis, it's positive. Between 13 and 20, definitely below the x-axis, again, negative. Okay, so remember, if the velocity function is negative, that means that the position is moving to the left. Okay, the particle is moving to the left. All right, if the velocity function is positive, the particle is moving to the right and then again to the left. All right. Okay, next thing that we can do is we can use the velocity function to help us analyze the acceleration. Because remember, acceleration is simply the derivative of velocity. So keep in mind, just like last time when we went from first derivative to the second derivative, that is talking about the slope. Okay, so if I'm looking for my critical values here, I'm looking for when is the velocity function, when am I seeing slopes that are undefined, so slopes undefined or 0. Those are my critical values, all right, on this sign chart. So if I start at the very left, the first critical value, the first horizontal tangent I see is right here, and that is at x is 4. So I'm going to put that here and put that as a 0 slope. All right, the next one I see is that here at x equals 8, and I would say that that would have an undefined, that's a very strong kink, so undefined slope. Also at x equals 11, same thing, I come to a point, and so that's another undefined slope. All right, next one is x equals, actually all the way from 15 to 19. At 15, I would say I would have an undefined slope. But then all the way through between 15 and then 19 was another undefined slope. And then you have another horizontal tangent all the way here. So I'm just going to put a whole bunch of zeros all the way in between 15 and 19 because those are all 0 slope. All right, so once I have my critical values on my sign chart, then I'm ready to go ahead and fill in pluses or minuses for acceleration. And so remember, if it's a plus sign, that's telling us, okay, what? Well, that means that the slope is positive there. The slope of the velocity graph is positive. If it's a minus, that would mean the slope of the velocity function is negative or decreasing there. Okay, so let's take a look at my intervals. So from 0 to 4, between 0 and 4, what is the graph doing? I would say that the graph's slope is negative, that it is going downhill. So I'm going to go ahead and put a negative here. Okay, between 4 and 8, what is the graph doing? So when between t equals 4 and t equals 8, I would say that the graph is increasing. So I'm going to go ahead and put a plus sign here. Between 8 and 11, I would again say it's positive. Then between 11 and 15, it's negative that whole time. We already put in all the zeros from 15 to 19, and then from 19 to 20, it has an increasing slope or a positive. Okay, so I have all those values in there. And remember, you don't put anything, we don't have any concavity, if you will, for position function. And so when we do the acceleration, we just need to fill in the top. We don't fill in anything for the position at the bottom. All right, so we're going to use those two sign charts now to help us to analyze and to answer a bunch of questions. Okay, so we're going to go ahead and start with the first question. And it just says, I don't know if you can hear my kids screaming in the background, but first one says, at what times in the interval 0 to 20, if any, does the particle change direction? Okay, changing direction is like changing movement. And when we're talking about movement, we're looking at the velocity. Okay, so this is asking us to look at velocity. In order to change direction, it would change from left to right or right to left. And so if you just kind of look at your arrows here, when is it changing directions? I would definitely say at x equals 8, and again at x equals 13. And the reason for your answer would be that v of t changes sign. Okay, part B, for all times t, find all times t during which the particle is moving left. So when is the particle moving to the left? Well, clearly, look at your arrows on your v of t sign chart. That would be the interval 0 to 8, and again from 13 to 20. And the reason would be because v of t is less than 0. Okay, next one. The next two questions are talking about the speed of the particle. So let's just review for a second. If we're talking about the speed of the particle, in order for the speed to be increasing, in order for the particle to be speeding up, that needs to happen when the velocity and acceleration have the same sign. Okay, the speed of the particle will be decreasing, or it will be slowing down when the velocity and acceleration have opposite signs. So they are giving us, for C and D, specific times that we need to look at. All right, so if they're giving me t equals 12, I need to look at what is the velocity when t is 12 and what is the acceleration when t is 12. And really I shouldn't have put an equal sign there. I don't want to know exactly what the value is. I want to know if it's greater than or less than 0. Is it positive or negative? All right, so v of t, if I look on my sign chart here, the velocity at time t is definitely positive, greater than 0. A of t, well, 12, A of 12, 12 falls here between 11 and 15, where it's clearly less than 0. So I have a velocity function at 12 that is positive and an acceleration is negative. Therefore, I would conclude that this particle is slowing down, okay, or speed is decreasing, slowing down, and the reason would be because v of t and a of t have opposite signs. Okay. Next one asks for the same information at t equals 2. Okay, so at t equals 2, what's happening? Well, I would say, first of all, again, same thing. I'm going to go ahead and say t equals 2, and I'm going to find v of 2 and a of 2. And I'm going to say, are they positive or negative? So if I go back and look, all right, I would say that v of 2 would be negative and a of 2 would also be negative. So both of them are going to be less than 0, less than 0. Okay, because they both have the same sign, both negative, I would conclude that it is speeding up, and that's because v of t and a of t have the same sign. Okay, and that's it. And those are the kind of questions that you would be asked. And again, I made this sign chart. You know, it might be a multiple choice question and you feel competent enough that you don't feel like you need to make the sign chart. And that's going to be up to you as you move through these questions. But the sign chart always gives you a clear picture of what's happening. So I think it's a good idea to take the couple, few seconds it takes to make that and then to answer your questions from that. Okay, this next question is asking us to analyze the graph of the second derivative, and we're going to be answering questions based on the fact that this is the second derivative graph. So again, I'm going to go ahead and make myself a big F double prime. So I remember I'm looking at the second derivative. Here's the thing about the second derivative graph. If you're given the second derivative graph, you can only make a sign chart for second derivative. You cannot go backwards to first derivative. And the second derivative only communicates to us about F. And so we could not just be given the second derivative and asked to make a sketch, okay? We wouldn't have enough information. We cannot be given the second derivative and ask for information about the first derivative. We are not given enough information. But we can use the second derivative graph to communicate to us about the original function. And so I can make my sign chart from -8 to 8. Okay? Now keep in mind this is the second derivative. So if you're making a second derivative sign chart from the second derivative graph, your critical values are when it crosses through the x-axis. Where are your zeros? Well, I can see here that I have a 0 at -5, at 0, and again at 6. So you are looking at the graph of the second derivative. It has zeros at -5. It crosses through the x-axis at -5, at 0, and again at 6. I'm going to put zeros up there. Okay, now I'm looking at the graph of the second derivative and I'm saying, where is it negative? Where is it positive? Where is it below the x-axis? Where is it below? Between -8 and -5, I'd say it's below the x-axis. Between -5 and 0, still below. 0 to 6, so from here to here. Okay, what's happening? The graph peaks above the x-axis, so we would put positive. And then from 6 to 8, it sneaks below the x-axis again, so negative. Okay, the second derivative communicates to us about the first derivative concavity. So I am able to conclude, wherever I have my negatives, that I'm concave down. And wherever I have my positives, I'm concave up. Okay, really quick, you should have been able to make that. And from that, now I can answer questions A and B and C very quickly. Okay, so, oops. All right, I had to scooch that up. Okay, so now I can answer the question, when is it concave up? Well, it's concave up right here, in this interval right here. So I would say from 0 to 6, it's concave up. And why? Because second derivative is greater than 0. Where is it concave down? So all the places where there's a negative. So from -8 to -5, from -5 to 0, and from 6 to 8. And the justification would be the second derivative is less than 0. Okay, for what values of x does the graph of f have a point of inflection? Remember, it has a point of inflection when you change sign. So where are we changing signs? I would say that we're changing signs here. We change from negative to positive, and here we change from positive to negative. And so we would go ahead and say at x equals 0 and at x equals 6, and the justification would be f double prime changes sign. Okay, that's all I have for you tonight. I know that was a little bit shorter, so hopefully you can use the extra time to do some studying and getting ready for your test. Thanks a lot, guys. See you in the class.